Okay, so we're going to discuss these questions on your tuition note. Let us start with question 22. Now, to understand this, let us take a practical example here. You pause the video and write this down first, and then replay it, and let us do this together below what you've written. Now, you will not be needing to write this on your answer script, but on your tuition note, practice note, you will keep it because it will help you to understand easily. So let us say a car travels between two places, A and B. Okay, between two places, A and B. So A is the 0 point, and between these two here is 40 kilometer. Then another 40 kilometer. That means 40 plus 40 is 80 kilometer. Then 120 kilometer, like that, and so on. Okay, 120 kilometer, and so on. So let us say, okay, 120 plus 40 is 160 kilometer. Then 160 to this point B, let us say it is 100 and plus 40. So there is equal gap of distance here, 200 kilometer. So let us say the car traveled from here 0 to 40, means covering 40 kilometer. It took 1 hour. Again, from here to here, 40 plus 40, another 40 kilometer, equal distance and same time. So if the car were to travel with the same speed like this in 1 hour, covering 40 plus 40, 160, throughout the journey he's covering the same amount of distance in the same amount of time, we know that is called uniform motion. So we are talking about this. So in uniform motion of this object car along the straight line road, let us say, or between A and B, okay, velocity remains constant, means unchanged. Velocity means velocity is distance by time or displacement by time. So here everywhere it is 40 by 1 hour, 40 by 1 hour. So velocity of the car was 40 kilometer per hour throughout the journey. The car did not increase or decrease its velocity, or in other words, speed, right? Such is called uniform motion. So in every uniform motion, we know that velocity remains unchanged, the speed remains unchanged with time. Okay, the car is the picture of a car going with the same velocity throughout. In this kind of a case, for any time interval, 1 hour, any time interval, change in velocity is 0. There is no change, right? See here, velocity is 40 kilometer per hour throughout the journey. So the car is traveling with the same speed. So there is no change in velocity, means the velocity is not 0. Velocity is 40 kilometer per hour, but the change is not there. So change in velocity is 0. Getting right? Okay, that's good. This type of motion where there is no change in speed or velocity is called zero or no acceleration. In other words, we'll say this car has no acceleration. It is having velocity 40 km per hour. Of course, it is moving, but there is no change in the velocity throughout the journey. So we say the car is having no acceleration. Okay, so having done what is no acceleration, so we tick there yes, having understood. This one is just to be kept for understanding. Okay, let's go to question number 23. You can do slow, I think it's okay. This will really help you during exam. Before exam, as you study, you don't need to draw this on your answer script, as I say. Now next, question 23. So what is no acceleration? We know now. It is the picture of a car whose speed is or velocity is same and no change in velocity or speed throughout the journey. Then acceleration must be the opposite. Let us just start with it. Write it down along with me, an example. Okay, example of acceleration of, we are going to now see what is acceleration. Acceleration in your daily life. So we'll take an example first, because that way it's easier for us to understand, right? Daily life, okay? And then define it. And then define this important word. In this class, we're going to discuss acceleration. So acceleration is a new word we're trying to understand in this chapter called motion, okay? Now here, let us take the example first. example is like this. Let us say there is here a car that first appeared. So it is traveling. This is the timeline, let us say. Now this is not distance. 0 to 1 hour. 1 plus 1, 2 hour. 3 hour, let us say. So for 3 hours we mark it's the pattern of the velocity, let us say. So in the first hour, when we first saw the car in 1 hour, it is traveling at this speed of, at the speed or velocity of, velocity is displacement by time, so kilometer per hour. Means in 1 hour it's covering 40 kilometer. Then in the next hour, the same car has increased its speed to 60 kilometer per hour. So you will see now, if you are seeing this like in a movie, okay, then first the car will be traveling with a certain speed, 40 kilometer per hour, but after 1 hour you will see the change in the speed. It will increase, that means. And then in the third hour, when you observe this car, you saw now it was traveling with 80 kilometer per hour. So in the first, second and third hour, this car is not having the same velocity. First 40, then it increase it to, the driver increase it to 60, higher speed. Then after 2 hours, increase it more to 80 at a high speed. So this type of motion where in the same amount of time, 1 hour, 1 hour, 1 hour, different amount of distance is covered is called non-uniform motion, right? So in this non-uniform motion, when there is change in the velocity, now we're showing change as here increasing 40 to 60 to 80, but it can also be 40 to 20, whether increase or decrease. If there is change in velocity of the object that is moving along the journey, then that is called change, that is called non-uniform motion. Okay, so in non-uniform motion, so here, let us say on a, okay, let us just write it down. A car travels on a straight line road. Let us imagine a straight line because we are primarily discussing straight line motion. On a straight line road, let us say a car travels with a velocity. A car travels with a velocity. So this is the example. Velocity of in the first hour 60, okay, 40 kilometers, 60, 40, 60 and 80. Okay, 40 kilometer per hour, then 60 kilometer per hour, and 80 kilometer per hour in the, okay, in the first, second and third hour. First, second and third hour. I hope you're writing along with me. That way it'll really help you. Open your tuition note textbook. Even if you don't have tuition note, then you can write it on your copy. Okay, first, second and third hour respectively. That means in the first hour it is traveling with a velocity of 40 km per hour, second hour 60, and the third hour 80 km per hour. That's the meaning of respectively. So this is an example. Okay, since velocity increases after each hour, so here since we can see very clearly velocity is changing, and how, in what manner? In the manner of increases, right? 40 km per hour velocity in the first hour. In the next second hour, it has increased to 60. So velocity increases after each hour, after each, okay, hour, that is, or you can also say equal interval of time, equal interval of time, okay, of time. This is an example of acceleration. So this is the picture of acceleration right in front of you, a car. So if you were to just imagine like this, 40 km per hour slower, then after 1 hour increasing 60, then after second hour it has actually increased more to 80. So that if an object, moving object, is increasing its velocity or even putting brake and slowing down, there is change in velocity, either increase or decrease. Such is called acceleration. Okay, now so we can now define. So acceleration happens only in non-uniform motion. Uniform motion means velocity is constant, does not change. So there is change of velocity is 0. But here change is what? 40 plus 20, 60. 60 plus 20, 80. So the change is 20 km per hour, right? But if the car is traveling 40 km per hour, 40, 40, then 40 minus 40 is 0, 40 minus 40. So there is no change in velocity. But so acceleration is a term connected to only objects that are moving with non-uniform speed, right? So here, let us write down. So for a body in non-uniform motion, so you can simply write your definition like this. This is the definition. For a body or object in non-uniform motion like this. So for acceleration to happen, the motion has to be non-uniform. There is no acceleration for uniform motion. We just read that before this question in 22. For uniform motion, acceleration is always 0, right? For a body in non-uniform motion, okay, velocity changes with time. We can clearly see that from the example. Changes with time. See here, after 1 hour, velocity change. In the second hour, 60. In the third hour. So velocity is changing after equal interval of time. Changes with time, therefore. Changes with time. For such cases, so for such cases means non-uniform motion. For such cases, for such cases, change in velocity per unit time. Change in velocity per unit time. Per unit time is called acceleration. So acceleration simply means change in velocity. Meaning of acceleration is change in velocity. It is a picture of a car increasing its speed all the time or decreasing its speed by applying brakes. So this velocity is changing all the time. That is called acceleration. Okay, so let us write the mathematical equation. So the equation would be, write down, if velocity of an object changes, if velocity, write it down, next paragraph, of an object changes, okay, changes from initial value u, from initial velocity is usually given by u, to final v in time t, okay, in time t, then, okay, velocity, let us put here v, then velocity v will be equal to initial velocity, okay, acceleration, then we can say here, then acceleration a, okay, then acceleration a is given by this formula here. Acceleration is, let's go back here, change in velocity per unit time. Focus on this area. This is the definition for acceleration. Change in velocity means change in anything is always final minus initial, never initial minus final. I repeat, change in temperature, change in velocity, anything change is always final minus initial. So final velocity minus initial velocity per unit time. The word per means divided by, time means simply now t. So this is the formula for acceleration, basic formula. Change in v minus u means change in velocity. Final minus initial velocity is called change in velocity divided by time, because per unit time means divided by time. Okay, so let us write it down. So just a side note here, just put it asterisk mark because you need to know this here. SI unit is not on your note, but you can write it. SI unit of acceleration A equal to okay, is, and then blank. Now let us do this. Use this formula. Below this, you can do this activity to understand it. Now, SI unit of velocity or initial or final is same. We know that. Meter per second. So we write here meter per second. We learned this in our previous classes as well as in the numericals. That SI unit of velocity is this one. So meter per second, meters per second. So that is it. Divided by time, the SI unit of time is second. SI unit follows the best units are this one, MKS, mass kg, okay, sorry, length for measuring distance, meter, mass kg, and time second, right? So this one. So this will be, if we shift this up here, oh sorry, per second means divided by time. Time is, SI unit of time is not second to the power minus 1 second. So if you shift this here to the numerator, you will get meter second into this one. No sign means plus, so no number means plus. It will go up means s to the power minus 1. So we need not write this. So this will be here meter minus 1, so per second square. The SI unit of acceleration is meter per second square. We have understood by applying this formula, right? Now having done this, now let us go to the next one. This is important question. It is a textbook question also. So you can open your textbook also and your tuition note also. Or if you don't have, just open your textbook. Question number 24. This is tuition note is 24, but on your textbook, it is actually activity. We have slightly, okay, activity 8.8. You'll find this on textbook, page 110. So let us go and look at the question on your textbook. Open your textbook to page 110. Write that number. Go to page number 110. There is a question there. This is an important question, good question in fact. In your daily life, you come across a range of motions in which you see that acceleration is in the direction of motion. So there are different types of acceleration. We have learned that basic difference is zero acceleration, no acceleration is the picture of a car in maintaining same velocity throughout the journey. Then acceleration means change in velocity, right? Means divided by time. Now another way of dividing acceleration is this. Acceleration is happening in direction of motion. Let us see one example from our daily life. Okay, so let us start with that. A example of acceleration in the direction is in the direction of motion. So write it down. Acceleration is in the direction of motion, is in the direction of motion. Let us take an example and then we will be able to understand this one. Okay, so here, so let us take this example. Our example are this one. I say libemo. Okay, pedals means put the pedal on the bicycle. Pedals. His bicycle. This is an example from daily life you can take. Bicycle from a stationary position. From a stationary position. From a stationary position to attain a velocity of 6 meters per second. So clearly the velocity is changing from not moving 0 meters per second, from a stationary means 0 meters per second, to moving at a high speed by pedaling. So that is clearly there is change in velocity. So this is acceleration, right? So in 30 seconds. So this is, okay, you can write here. This is an example of acceleration in the direction of motion. Okay, so we can take like this. So if the bicycle or the car is moving like this, so acceleration in the direction of motion, and then you can write at this one acceleration in the direction of motion, or it is also called positive acceleration. So first type, positive. So what is acceleration in the direction of motion or positive acceleration? It is the picture of a car or bicycle like this. So initially it's at rest or even moving also slow, and then you pedal more and the bicycle increases. So positive acceleration or acceleration in the direction of motion are same, means it is the picture of a car moving out from the garage and increasing its speed slowly and moving at a very high speed. Okay, that is called positive acceleration. Okay, now here B. Second one is acceleration is against the direction of motion. So you write your acceleration. Second example we have to give is against the direction of motion. Example here, you can just give a simple example. You should not have given a different example. Okay, here you can just give an example. Okay, a car traveling at a velocity of 50 km/h. Let us say a car traveling at a velocity of 50 km/h applies brakes. Okay, applies brakes and stops after 10 seconds. So it is the picture of a car traveling with a high speed of 50 and then the driver apply brake, so it's slowing down, so velocity is decreasing, changing. Finally it came to stop. That kind of a change in velocity or that kind of acceleration is called acceleration against the direction of motion. So this is an example of acceleration against the direction of motion, or some textbook call it as or negative acceleration, or they also call it as deceleration. Some textbook call it as deceleration or even retardation. Okay, so acceleration against the direction of motion. So these two are opposite. Acceleration in the direction of motion or positive acceleration is the picture of a car starting out very slowly and increasing its speed. And then negative acceleration or acceleration against the direction of motion is the picture of a car traveling at a higher speed, applying brakes and slowing down and maybe stopping also. Not necessary to stop, but with a car applying brakes and slowing down, okay, and may come to stoppage or not come, but if it is decreasing in velocity, that acceleration is called negative acceleration or acceleration against the direction of motion. Okay, then C. In this question, C is we have to give an example from daily life. So here C of what? Acceleration is uniform. So acceleration is uniform, or this is also called uniform acceleration. So look here. Draw this picture first, which we don't need to do in exam. Uniform acceleration means throughout the journey, let us say in the first hour, 0 to 1 hour. Okay, 1 hour. 0 to 1 hour. This is traveling at, this car is traveling. This is not the road, this is the timeline. Let us say it is traveling at, when you first saw it, then it is traveling at, let us say 20, or say, let us say 40. Then after 1 hour, another 1 hour, you look, so 1 hour plus 1 hour, 2 hour, it is now 60 kilometer per hour. Then after 3 hours, after 1 hour, in 2 hours, 60. After the second hour, for the next 1 hour, it is traveling at a different velocity, 80 kilometer per hour. Kilometer per hour. Okay, so here we can express it in the way that you find it convenient. Hour. Okay, so here you see here the change here after 1 hour. There is a change in velocity after each hour. So this is acceleration. If it was 40 kilometer per hour, 40 kilometer per hour, 40, then that is uniform motion. So there is no acceleration. But here 40 and jump to 60. After 1 hour, jump to 80. But the increase is uniform. You see, after 1 hour, here to 40 plus 20, 40 plus 20, 60, 60 plus 20, 80. So the change in velocity is equal, right? Change of velocity is equal in equal interval of time. 20, it's not like 40 then 60 then 40 plus 20, 60 then 60 plus 40, 100. No, 20 plus 20 after each hour there is equal increment or equal increase in velocity. So that is, this type of acceleration is called uniform acceleration. So let us write it down in the form of language. So here, a car on a straight line road. A car on a straight road, you can also write like that, travels with a velocity of 40 km per hour, 60 km per hour and 80 km per hour in the first, second and third hour respectively. Let us say we have a car like this moving on a real road in daily life. This is an example of uniform acceleration, or acceleration is uniform, or we'll say this is uniform acceleration. Okay, then finally one more example, D. I think D, the last example before this class ends. D, they are asking us, or D for D, they are asking us acceleration is non-uniform. So here acceleration is non-uniform. We have to give an example of non-uniform acceleration. See here, because of crowdedness of a street, let us say busy traffic. Okay, so in 1 second, 0 to 1 second, a car is traveling with velocity of 2 meters per second, 2 meters per second. But since it is more crowded after 1 second, it is entering a more crowded area. That means here after 1 second, 1 plus 1, 2, it applied brake and the car slowed down 1 meter per second. And then again after 1 second, let us observe its pattern, 2 plus 1. So after in the next second, after 2 seconds, it is traveling with a higher speed because the street is less crowded. So here we can see after 1 second, in first second velocity was 2 meters per second. In the next second decreased to 1 meter per second. In the next second increased to 3 meters per second because of the crowded nature of the street. So here there is change of velocity throughout the movement of the car, but it's not uniform. 2 minus 1, 1, 1 plus 2. So the increase or decrease is so ununiform. This type, and still there is change in velocity. So this is acceleration. So this type of acceleration, which is like happening in a non-uniform fashion, is called non-uniform acceleration, or acceleration is non-uniform, we say. So here, example, let's take here, example. When you now draw this in your exam, here now you draw, it will help you to understand. A car moving through a busy traffic. A car moving through a busy traffic. Moving through a busy traffic on a straight, okay, on a busy traffic, moves with a velocity of, let us say 2 meters per second, is covering 2 meters in 1 second, then 1 meter per second, and 3 meters per second in the first, second, and the third seconds of time. We are talking about time, okay? This acceleration is non-uniform. This acceleration is non-uniform, or we can simply call it as non-uniform acceleration. So this is the example, the 4 examples that the question is asking. Can you identify any one example each? Yes, we have done. So in this one we have discussed with this one. First one, A, is acceleration in the direction of motion, or positive acceleration. That is the picture of a moving object gradually increasing the speed, like a car picking up the speed. Then the next was acceleration against the direction of motion, or negative acceleration, is the picture of a car applying brakes and slowing down. Then the next was uniform acceleration, where a car is moving at 40 km per hour, the next 40 plus 20, 60, the next hour 60 plus 20, 80. So there is increase 20 km per hour increase. So there is change of velocity, but the change is equal. So that is uniform acceleration. Here in this last uniform acceleration, non-uniform acceleration is the last one, D, non-uniform. Here it is the picture of a car moving through a busy traffic. First second it is moving 2 meters per second. Then suddenly the street is crowded, so I applied brake, slowed down to 1 meter per second. Then in the next second it was more clear, the road, so it increased the velocity. So that kind of change of velocity, which is not uniform, is called non-uniform acceleration. Okay, so as I said once more, negative acceleration, positive acceleration, negative acceleration, uniform acceleration, and non-uniform acceleration. These 4 we have discussed in this activity. Okay, this is important. We'll discuss the remaining, okay, in the next class.